Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwa Sos Ukobela Wemets. And without any further ado, let's look at this question that we have here. Okay, so we have question 5. It says the table below shows the relationship between the melting point of 3 molecules, and then 3.1 says define the term melting point. So how do we define melting point? We say this is the temperature at which the solid and liquid phases are at equilibrium. Right. Then there goes the definition for the melting point, the temperature at which the solid and liquid phases are at equilibrium. So that's the definition that they expect for you to get those 2 marks. Right. Then let's proceed to 3.2. 3.2 says explain the trend in melting point of the molecules in the above table by referring to the intermolecular forces and energy involved. Now, having to look at this, we can see that our molecules here, we have CH4, CF4, CCl4. What we are observing with these molecules is that all these molecules that they've put in here, they have what we call the London forces. And then another observation that we can make is that as we go down the table, the molecules are increasing in molecular size or molecular mass, right? So now, answering this one, I have a method that is called the ISSE method. So this is where, number 1, I speak of the intermolecular forces that are involved there. So we have to identify the intermolecular forces. And then on this S here, we speak about the size. So that's molecular size. And then this S here, we speak about the strength of the intermolecular forces, right? And then for the last part, E, we speak of the energy involved, right? So the energy involved, or the energy that needs to be overcome, right? So following that, the ISSE method, we use it if we are to compare molecules that belong or that have the same intermolecular forces, right? So the ISSE method is used only for molecules that have the same type of intermolecular forces. So if we can first identify that the molecules involved in that investigation have the same type of intermolecular forces, then we follow with that structure. Now, you can see that's 4 points. That will give us 4 marks. So how do we start with that? Number 1, we have to tell them all 3 molecules that we are given here. So all 3 molecules have London forces. So now, once they can say that you have identified the intermolecular forces, the London forces, then that's a key that will give you a mark, right? And then point number 2, this is where now you speak of the size. So we'll say the molecular size increases from CH4 to CCl4, right? So now we are telling them that as we move down the table, the molecular size is increasing. Even if you can check from your periodic table, you would be able to do that. If you can just calculate the molecular mass of each and every molecule here, you would find that the molecular mass is increasing as you go down the table, right? So once you can tell them that, that's another mark, right? And then now we are speaking about the strength of the intermolecular forces. So we'll say the strength of the London forces. So the strength of the London forces increases with an increase in molecular size. With an increase in molecular size. So what does this mean? It means that as the size of these molecules become bigger, even the strength, even the intermolecular forces in between them, they become strong, right? So the strength of the London forces increases with an increase in the molecular size. Now you have mentioned at that point, right? Then the final point you want to tell them is, now, this is where you speak of the energy involved. So we will say more energy will be required, or you can write needed. More energy will be required to overcome the London forces. The London forces in molecules with a higher melting point. So let me write MP. So melting point. But remember, you have to write it in full, right, when you are in your exam room. Then, okay, let's go over our points. So number one, we said all three molecules have London forces. Then number two, the molecular size increases from CH4 to CCl4, and then the strength of the London forces increases with an increase in molecular size. Then more energy will be required to overcome the London forces in molecules with a higher melting point. So that's how you go about answering that for 4 marks. Right, so now let's proceed. So obviously you have your final mark there for this. So that's 4 marks. Then 3.3 says, which molecule in the table will have the highest vapor pressure at a given temperature? Explain the answer by referring to the data in the table. Now, when you refer to the data in the table, you can see that there is no sign of the vapor pressure there. We are only given the melting point. So the question is, how do we answer a question that is asking us about the vapor pressure when the only thing that we can see there is the melting point? Now, this takes you to your relationships. Now, you have to know that the relationship between the melting point and the vapor pressure is actually inversely proportional. So what is the meaning of this? If we are looking for the molecule with the highest vapor pressure, then this will translate to the molecule with the lowest melting point, because these two are inversely proportional. So that means a higher vapor pressure translates to a lower melting point. So that's how we're going to figure it out. Now, looking at the numbers here, we know mathematically, if the numbers are negative like this, we will say the one that is bigger, but the negative is the smallest one, right? So we know that negative 23 would have to be much greater than negative 182.5. So the one with the lowest melting point has to be the CH4, right? So in answering 3.3, we will say CH4. And then they say, explain the answer by referring to the table. We say it's because it has the lowest melting point, right? So again, we know lowest melting point translates to higher vapor pressure because of the relationship. MP is inversely proportional to vapor pressure, right? So that's how you answer those questions. Then let's proceed to 3.4. Now they say water H2O is a smaller molecule than CCl4, but water has a higher melting point than CCl4. Explain the observation by referring to the type of intermolecular forces involved. Right. Now, we've already identified that the intermolecular forces in CCl4 are the London forces. So obviously, if we are referring to the type of intermolecular forces, we have to mention it again. So we'll say CCl4 has what? Has London forces. Has London forces. Where else? So we can say has London forces only, right? Whereas H2O has both London forces and the strongest intermolecular forces, which are the hydrogen bonds. So H2O has both the London forces and hydrogen bonds. Now, obviously, what makes it to be much more stronger, what makes the intermolecular forces of H2O stronger than those of CCl4 is the fact that they have the hydrogen bonds. So we'll say hydrogen bonds are stronger than the London forces. Now, obviously, we do understand the relationship that the one with the stronger intermolecular force will have a higher melting point, right? So why is it so? It's because intermolecular force is directly proportional to the melting point, right? So obviously, a stronger intermolecular forces, higher melting point, right? Then that's how we explain the observation. Then to answer 3.5, what is 3.5 saying? So it says, write down the name of intermolecular force that will exist in a mixture of H2O and CCl4. Now, in order to understand this, let's understand H2O. We refer to it as a what? As a polar molecule. And it's a polar molecule, and it is also permanently dipole. Right, so this is a dipole. Then our CCl4, on the other hand, is a nonpolar molecule. So nonpolar molecule because it possesses as an asymmetrical geometry according to our atomic combinations, so they still apply. So it is an asymmetrical geometry, and therefore it is nonpolar because the dipole moment in here, so we say the dipole moment in here is 0. So dipole moment is 0. Now, we know there is this type of intermolecular forces that we usually possess. If we want to take a permanently dipole molecule, which is a polar molecule, and then we combine it with a nonpolar molecule. So we know that this polar molecule or this dipole molecule will induce a dipole in this nonpolar molecule. So now if we say that this polar molecule will induce a dipole in this nonpolar molecule, we know that the type of intermolecular force that we have there is called the dipole-induced dipole. So that's dipole-induced dipole. So the one that will be dipole-induced is the CCl4, and then we have the dipole, which is the H2O, which is inducing this nonpolar molecule. So that's dipole-induced dipole forces. And then that's how we were supposed to write all that. So, okay, that's all of your question for 12 marks, meant to say. So you know what to do. Please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.